Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Let's go. Electricity. Electricity is a set of physical phenomena which is associated with the presence and motion of matter that exhibits a property of electric charge. The electric charge that is produced can either be positive or negative, and it can induce an electric field around them. The movement of electric charge is called as the electric current, and it creates a magnetic field. There are two types of electricity: static electricity and current electricity. Static electricity. Static electricity is an accumulation of electric charges within or on the surface of a material. Static electric charge is created when two surfaces come in contact, rubs with each other and separate, and one of the surfaces has a higher resistance to electric current. The charge remains in the material until it is discharged by means of an electric current or an electric discharge for neutralization of the charge. The material which gives up electrons is more positively charged, whereas the material that accumulates more electrons is negatively charged. Types of static electricity. The static charge that is produced can be experienced as it is felt, heard, and seen. The charges are trapped there for a long time enough so that their effects are observed. These charges are either quickly discharged or get neutralized slowly. An example of quick static discharge seen in nature is the lightning. Other examples of static charge are static clinging of clothes, balloon rubbing against hair attracting small particles, amber rubbing against wool, fur rubbing against acrylic rod, plastic against rubber, etc. When different materials come in contact, materials with weakly bound electrons lose them, while those with sparsely filled orbitals will gain electrons. This is called triboelectric effect. Importance of static electricity. The electrostatic charge that is induced is due to multiple causes, which include contact induced, pressure induced, heat induced, charge induced, etc. The buildup of static charge is discharged as excess charge is neutralized by the flow of charges to or from the surroundings. This discharge of static electricity to the body can result in electric shock and burn. The feeling of electric shock is caused by the stimulation of the nerves as the current flows through the body. Several electronic devices are sensitive to the presence of static electricity and can be damaged by static discharge. The flow of finely powdered substances and low conductivity fluids flowing through the pipes or mechanical agitation of these substances can build up static electricity. Industries dealing with these materials are much more prone to static discharge and explosion. Static electricity can be dangerous in fueling operations such as aircraft refueling of inflammable substances like gasoline, toluene, xylene, kerosene, etc. Static electricity is used in various applications such as in crystal microphone, Xerox machines, laser printer, etc. Protection from static electricity. Several electronic devices are sensitive to the presence of static electricity and can be destroyed by the static discharge. To protect semiconductors that are sensitive to static discharge, conductive anti-static bags are used to carry them. People who work on sensitive electronic devices ground themselves with anti-static wrist straps, anti-static gloves, safety boots, etc. Static discharge from the lightning can be avoided by disconnecting all external antennas or data cables connected to the devices and appliances at homes. Power lines can be switched off to cut off the lines. Lightning protection devices may be used in electric wiring to provide safety. Good earthing system helps to discharge any small static charge that persists in the electric wiring system. A lightning arrestor can be mounted on the top of a building and it is effectively grounded to prevent damage over buildings. Always avoid using water pipes or shower when there is lightning. Also avoid standing in the open under a tree or ride a vehicle. Always move to a safe location away from the direct strike of the lightning. Here I am going to demonstrate the existence of static charge on objects and materials. Now I've got a piece of paper here, and I'm going to cut it into small pieces. Into small pieces. Here, this two need to be further cut into smaller bits of paper. So we have smaller bits of paper here, and we are now taking a plastic scale. This is a plastic scale, and this is used for office purpose and used by in schools and colleges. This is a Natraj. You can see it's a Natraj office scale. And I'm also taking a piece of rubber. This is the rubber, and you can see the right now I'm keeping the scale very close to this paper, and it does not actually it doesn't actually stick to the scale. It doesn't have any sticky surface on this side, and even if you make it in very close proximity, keep it very close to the scale, it is not sticking. The papers are not sticking to the scale. And now when we actually rub the scale using a rubber, this is a eraser, it's made of rubber. This is an eraser, the office or school eraser. Now we'll just rub the surface of the scale using this rubber. And now we'll hold it close to the scale. Now you can see that most of the paper has just stick to the scale. You can see it is sticking to the scale. So this is how the actual the static charge that is collected in the scale, which is showing its influence on the paper. It attracts the paper, the pieces. So now when I place it close to the paper, here you can see most of the paper sticks on the surface of the scale. So this shows that the positive charge on the scale, that is because the electrons are ripped away from the surface of the scale, which makes the surface of the scale a bit positive. Most of the negative electrons have been taken away or rubbed from the surface using the eraser, so it becomes positively charged. And now when you this positive charged atoms on the surface of the scale, it exerts a force on the nearby objects, like the paper, like the small pieces of paper here, and it sticks to the surface, the scale surface. This positive charge always exerts a force to attract more electrons into its valence outer orbits. This is especially seen in insulator materials like plastic, rubber, wood, or PVC, or materials like that, and it doesn't this property is not often seen on the conductor on the surface of a conductor, because it can always discharge. The charge can always be neutralized. Here on the surface of an insulator, the charge is accumulated. You cannot conduct the charge away to neutralize to the ground, or maybe to a more neutral surface. Now I am rubbing this end portion of the scale. We are placing the scale away from this region. It's actually we rubbed on this part of the scale, but we are placing it away from that end. But we don't see the paper sticking here. We don't see any paper sticking here. But when you place it near to the end of the end region, now the paper sticks. This shows that this is being an insulator. The scale is being an insulator. It does not conduct this charge. The charge is isolated only at the end of the scale. It is never conducted to any other side of the scale. So this is how the static charge affects our day-to-day lives. Most of this phenomenon is seen mostly on insulator materials.